Gmail now. And see, you are getting hi username. So whatever the username would be there, like whatever you will write there, and you'll be getting up there, right? That is hi username. So I think this would be like very clear to you, right? This is how we use the split one, right? Now, if in the EM, we're gonna count that how many you are there, so you'll get 0, right? How many username are there? So you'll get 1. Understood? So that is exactly, if you see your EM, you'll have gmail.com and you will have username. So this is like how you can count up the things. Okay? And even you can just find up the index values too, right? If you just go for index of username, you'll get the username index is 0. That is the first one. It is having the starting. I hope this will be clear to you. Right? Similarly, we can go to more of these string methods, like we can go for indexing of the things. Now we know this EM is a list, right? If we just only for this EM of 0, this is username. Similarly, EF till 1, right? EM till 1, we get the username only. So these are some of the indexing methods what we can do up there. Okay, fine. All right, next one. Now let's say this is your string which is having some of the spaces. All right, this is having a lot of spaces, and you run this, you'll get the output exactly of how you write, right? Now let's say you're using this here strip method and you'll run this, and you can see the difference, right? What is the difference is that the strip method, what you use there is the spaces has been removed to just non-spaced, right? This is an output with some unspaced characters, right? That is safe, right? I think that is good. Okay, now, so similarly there are a lot of things, right? Let's say this is a statement which is this is a statement posted on this, and now I can give a format over there. Posted on for whatever you want, you can write up, like you want 21st or today is 18th. You can run this and you can see the outcomes to be that this is a statement posted on. So this is exactly a format method. You will get 18, 8, 20, 20. All right. So these are the basic ones, right? So this is all about the strings. Similarly, now we'll go up to the list. So list is nothing but you can see there is a kind of heterogeneous elements present over there, right? Of heterogeneous elements mean that you will be having some heterogeneous data type of elements over there. Okay, like you can see up there. So heterogeneous data type means that let's say this is a list L, right? And here you can have integer, you can have a float, you can have a complex, you can have even one more list, you can have even the tuples over there, you can have even the sets, you can have the dictionaries, and like this. So you can have a lot of this, right? Different type of data types over there in one particular list. And the most interesting thing is like you can even repeat up your elements, right? So you can repeat up the elements. Okay, that is a cool method in this list one. So if you see list of 0, so this is 12. Similarly, list of 1, right? Okay, so instead of going for all of these things, what I'll write for x in L, print x. So we'll see all the elements of this x, right? That is, one is having 12, 23.4, 45J, 12, 12, ACB, and A1. So these are all of the elements inside there. Okay, I think it should be clear. Suraj Verma is asking, please repeat for 24th line. Alright. See here you are having some spaces over there, right? So strip method is used to remove the spaces from the beginning and the ending of your line. Okay, fine. Let's just say, so let's start particularly like things in the array you are having in the C, right? So this can store elements of different types built in the array methods, and it's a versatile data type available in Python where you can store multiple data types inside that, right? So you can index over the things, you can even slice the things, right? So let's say you want EM 2 to 4. So you'll be getting 2 and 3 elements, that is 45J and 1, 2 like that, okay? Alright. So there are a lot of operations you can do on the list, right? So let's say for seeing up all the operations, you can just quickly write help of this list, and you will get up all the things like the add, contains, element, those things, right? So you can do clear, you can do extend, index, insert, pop, you can go for even sort, reverse, and a lot of operations are there. Okay. Moving on. So let's say you went for marketing up there, right? And you made a bill, right? You made a bill. So let's say you went for going up for the shopping, and your bill was like, let's say you purchased an item for 1443.0. Then you made a purchase for 367 something for 9, and like that, right? So let's just take it some other things. So you made a shopping of these things, right? So you have prepared up the things that will be investing up these much money in the shopping today, right? And this is your shopping list, what you have made, right? These are the prices what you have made. Now you went for the shopping. So what was your total budget, right? If you see your total budget of shopping, that is the sum of the shopping. That is, your budget was around of 8,600. Let's say around of 8,700 kind of, right? But meanwhile, in the shopping, you came with one or two products with the interest, right? And you bought up them, right? So what you will do is you will add up those things inside your budget values, right? So how to add up things in a list? So you can add, you can use append, you can use extend to add up multiple values. So let's say you bought only one element up there, and that was costing around some 654.2, right? So now if you see your shopping, you can find up there the things to be 4 elements. Okay. Now let's just say, now what is the now once you have purchased all those things and you came back to the home, right? You will be seeing that what is the costliest item or what is the costliest product you have bought. So that will be the maximum of the shopping, right? So the maximum of the shopping will give you the costliest product you have bought on, right? Similarly, like what was the overall budget now? That is the sum of the shopping. So your overall budget came to be 9,380, right? So here we can see this is how list works actually, right? So you can even make some duplicate elements, you can add up the elements, you can remove other things, right? So this is how list works. Now similarly, there is a data type called as tuple. So in tuple, what happens? Tuple is also like a list, right? But focus on that is like a list, right? It works like a list. That is, it can store various elements up there, right? So it can store heterogeneous types of data inside that. But the main thing is that in the tuples, you cannot edit the elements. Edit the elements in the sense that once you make up the things, right? In the list, you can change it. Like let's say this is your shopping list, right? Or let's say this is your L. What is L? These are having some of the numbers. Now let's say in the L of 0, I want this to be replaced. So if I see my L, I can see in the 0 position it's replaced. But it will not be done in the tuples. In the tuple case, it will not be a possible one. So tuples are a sequence of immutable Python objects, and the list are for the mutable ones, right? So let's just say this is similar to be a tuple T, and the tuple you can make it with a rounded brackets. Okay, so let's say you make some 1 to 8 over there, some elements 1 to 8 to 9 up there, right? That is exactly what a tuple is. See the type of T, to find it to be a tuple. Now what I am saying that in the tuple you cannot edit up like this. Now, let's say this is of T of 0 and you want it to for any element, right? Let's say ER. Just run this and you will get an error over there, that is a type error, and it will say that tuple object does not support item assignment, right? Okay, so alright, I'm is asking tuple is faster. Alright, so tuple is exactly faster than the list, right? So if you are just defining a constant set of values and you just want to iterate up the things, so iterations are always faster in the case of the tuples, right? Iterations are very much faster, right? So when you define a constant set of values, you just want to iterate, and there you actually use tuples instead of list, because that in that case it is being faster, right? Okay, fine. Tuples are immutable means we cannot make up any changes once we execute them. Yeah, so you cannot make changes. There are possible ways to make up changes, but it is actually not possible, right? If you just go for definition, right? Like you can say an official definition with the tuples, these are immutable, right? So let's say we want to, anyhow, we just want to replace this 1 by ER, and we want to replace, right? So what is the possible ways? So there you have to first make it a list, and then you can make the change, and then again you have to make it a tuple. So basically you cannot change a tuple, or you cannot change the element, you can't replace the elements of a tuple once executed. So if you see your T, you'll be seeing that these are 2, 3, 4, 5, 6, 7, 8, 9, and the first element to be ER. So this is how you can change. That is exactly, first you changed a list, right? First you change it in a list, and then, so in the tuples you cannot do anything, right? You can convert in some other types and then you can go for that. Similarly, guys, when we talk about this additions and subtractions, or let's say the additions and the removals, so let's say you want to write this t dot pop, any method which is common method. So tuple object has no attribute of pop, right? You can't just remove other things over there from there. Okay, once you define, you can't just remove other things. That is also an you can say restrictions of the tuples. Okay. So let's say you just want to add something. You cannot use add, you cannot use append, you cannot use extend and all. So what you can use is, you can use another tuple itself. And that can be done. See, 12 has been added up. Okay, this is tuple all about. Similarly, there is sets and dictionaries. Okay, we'll not be going on much in the sets one, right? Set is particularly like we have been reading in class till class 11 and all, right? That is an unordered collection of items where every element is unique, right? So let's say this is X and this is about 1, 2, and you run this. You see your X, you'll be only seeing 1, 2. There is no duplications of the IDs. Oh, sorry, no. no duplication of the elements. Okay, you can find up the unions, you can find up the intersections and all with this. So we want to just focus on the dictionary parts and the data science parts. Okay, so let's say this is a dictionary and its name is, so this is like Aadhaar, right? What you have there actually is, the very first thing is to be a name. So let it be the name, AD username. Then you have there the number, right? Then you have the Aadhaar number there, and that is like 16 or 17 digits some number. Something like this, right? Then you have your addresses and all those stuffs, right? Then you have this address. Alright, so let's say this is an address. And let it be anything, right? Any address. So not giving any specific things. So this is how you actually make a dictionary, right? So let it be up there. And run this. So, alright, got some. So here must not be a spaces. If you want a spaces, you can make it in a string. Right. So this is a dictionary bit particularly. You see your Aadhaar. Right, this is a dictionary. Now, what are the keys? What are the basic things? What are there in the Aadhaar? So that is the keys actually. So name, Aadhaar number, and the address. Right. So these are the keys of your Aadhaar. Right. Every particular. So this is a dictionary actually. Right. So if I just say you in a very basic example why I took the example of Aadhaar card, right? So for like who don't know about these Aadhaar card, it is like a unique ID which is being given to all the Indian citizens, and for every Aadhaar number there is a name and few other details attached with it, right? So we are taking some of like Aadhaar number and the addresses there. Okay, fine. So you can consider this Aadhaar name or the number or the address as the keys and the details of the person as the value. There you have a key value pair in the dictionary. This is how it works on. Now if you see for X in Aadhaar dot items, print X. So we can see all the details, right? The name is the username, Aadhaar number is this, and the address is this. So simply you can make up a lot of things over there with some different one, right? We'll be making up this thing, right? So let's say there are some more names. Just say it to be hello. Like this. Okay, I've got some of the commas issue. All right, done. So type of Aadhaar is still dictionary. What are the keys? Still this. But when you run this, you'll see in the name you have username and the hello. In the address you have two contents. In the address you have again two contents. Like the Aadhaar number you have two and the address two, right? So these are the basic structures of how you make a dictionaries and all those things, right? Now with the help of a dictionary, we are just now going to enter in the data science packages, right? So with the help of dictionaries and all, we come up in the data science tools. Okay. So we'll quickly start up with the first thing, that is matplotlib. Okay. So what is matplotlib? So matplotlib is a plotting library used for 2D graphics in the Python programming language, right? It can be used as Python scripts, as shell in the web applications, or you can say the GUI, right? So that is exactly. So matplotlib is not like a part of all the standard libraries which come by default in the Python, right? So there are several toolkits available in this Python matplotlib functionalities where you come with the base map, Car2P, Excel tools, mplot3d, and nat3d, nat grades, and all kind of that. So you go up with it. So if you just make it a simply thing that this is a uh, plotting tool in your Python language. Okay. So how many kind of plottings are there, right? You have bar plots, you have histograms, you have scatter plottings, you have area plots, you have pie plots. Okay. So you have plots in various kinds actually. Alright. So we'll quickly see up like how we can just plot our data in the matplotlib. Okay. And we'll then go with the Numpy part. So let's say this is your x, which is having 1, 2, 3. Similarly, this is y equals to 4, 5, 1. Now let's say we just want to plot this. So we'll be plotting x and y, but before that we'll have to import this matplotlib. Right? And we'll just plot it there. So we'll get this one. Right? That is a basically a graph of this 1, 2, 3 versus this 4, 5, 1. Right? So how to see where is 1, where is 4 and all these things. So in that case, we can mention it, right? That is x and y in some yellow dots. So in this case, you can find up all the points, that is, this is y, or this is 1, or this is 4, 2, or 5, or 3, or like condense. Okay, I think this is clear, right? Like this, you can find up things over there. Now, similarly, if we just don't plot this directly, just let's see with this content, we can find all the dots, that is the scatter plottings. Okay, so we'll go up in this matplotlib section after we complete the numpy, right? Now if we talk about the numpy, so numpy is a Python package which stands for numerical Python, right? So this is a core library for scientific computing, which is a very powerful n-dimensional array object, right? So why we use this numpy and where are we used? Okay, so this provides you an interactive tool for C, C++, JSON files and all, right? So it is also used in linear algebra, random number capabilities and all. Okay, fine. So very first thing is like you have to first import the numpy as np. Run this. Okay, so this is the first thing we do, right? Now what is a numpy array? In this numpy we'll be going up with the numpy arrays. So numpy arrays are the powerful n-dimensional array object which is in the form of rows and the columns, and here you can initialize your numpy arrays with the nested Python list and the and you can even access all the elements there like you do in the list, right? It's very pretty similar to the kind of things you do in the list. Okay, so in today's, we'll be also seeing that if you want to calculate some mathematics section, how you can go up with those things, how you want to, if you just want to plot up those things, how you can just go with that, right? So we'll be going up with those things also. Okay. Now, once you have imported this numpy, like once you have done with the array parts and all, so now we are going to create some arrays, right? That is, let's say this is a and this is to be np dot array. So we see the dimension of this array, that is one dimension, right? So you can easily find out the things with the brackets. Like if it is one bracket over there in the starting, that is particularly your one dimension. Right, if it is two brackets, then two dimensions, right? Easy things, okay? Not to be must with a, okay? So these are the basic. One bracket, one dimension. Similarly, let's say this is an array x and this is np dot array. 1, 2, 3, 3, 4, 5, 6, 7, 8. So see the number of dimensions you're having this, right? And what is the data type of this one? That is D type. So you'll be getting, and even you can see for the data type names too. That is integer of 64 bytes. Now what are the item size you're having here? So that is 8 bits, right? And what are the size exactly of this array? That is total number of elements present is 9. Okay, that is how we do, right? So in Numpy particularly, we make it more use as compared to the list, right? Because it saves much time in doing some operations. It also saves times in storing the values, right? Okay. Now we just try to understand, like if I have written an x and I am seeing that the number of dimensions is 2, then what does it say? This is 3 by 3. Cool. So 3 by 3 means that we are having 3 rows and 3 columns. Understood? 3 rows and 3 of the columns. So that is fine. 3 rows, 3 columns. Now let's say if I make an array of y dot shape. Now what you'll find here is 2 cross, nothing else, right? That is 2 cross. So there is no particular linearity in the elements over there. Then you'll get a same shape like this. Let's say this is 3. You get 2 cross 3 now, right? So there is some sort of linearity in this data now, right? They're having 2 rows and 3 of the columns. Okay. Now let's say you want to reshape this. If you see your y, this could be 1, 2, 3, 3, 4, 4, right? Now in case if you just say you want to reshape this in some different attributes, 3 by 2, so you'll get something like this. Okay, so data would be represented. The data will be represented by the 1, 2, 3, 3, 4, 4. Nice, right? This is something on a reshape. When you change the number of rows and the columns with a given new view to your object. Okay. Now let's say if we just quickly want to see just how to represent the numbers and all, right? If you just want to see how to present up all the numbers and how to go up with those snippets. So what we can do with that, right? Like if you want to solve a mathematics problems with the help of a linear equation, in the like you want to just represent some mathematical equations in this Jupyter notebook. So what you can do in that case, right? Okay. So let's just say this is I'm importing Sympy. Or let's say from this importing all the modules. Okay, now guys, let's say I'm having a number 1.3. Okay, and that is being printed up there, right? That is being printed up there. But what if I write it as float, and if I write it as 1.33333 and I give it by 2, just run this, still I'm getting 1.3. Why? Because like I have written up a number which is like non-terminating over there, and there we have written it to be 2, right? So that you'll be only getting one float value, or you can say the total number of outcomes you'll be getting is, or the total numbers you can see in your outcome is 2. So you're getting up there. Now if you write up 3, see the difference, right? Okay, so that is how. Now let's say I have this 1.3 and I want this to be a rational. Let's say I want to just present this 2 by 4 in kind of a rational representation. This 2 by 4, that is 0.5, right? So if I write rational of 0.5, so I'll get to be 1 by 2. That is 2 by 4 is actually equals to 1 by 2, right? We just see on for that. So 0.5 is 1 by 2, right? Similarly, if we just want to say that I actually want to get this as 2 by 4, we want 0.5, and I'll be limiting my denominator. So limiting the denominator to be 100. So still you'll be getting up to be 1 by 2. Okay. So these are some of the kind, like if you want. Now, but let's say this is 1 by 2, right? But I want 2 by 4 only, right? I want this 2 by 4 to be presented, right? So there I can use string methods again, right? But how? Let's say this is my x, which is a rational of 2 by 4, right? If I see my x, this would be 1 by 2, right? But in case if I say that my numerator, what is being presented should be, in case, let's say this to be this, okay, and let's give a denominator. And use the format method, right? And the format, you can write up that you want the x dot p, and write exactly what is the fractional value of this, what is the format of writing any fractional value in the form of p by q, right? So you can write x dot p and x dot q, and when you run this, you'll see numerator and the denominator to be 1 and 2, right? Okay, so that is how. Let's say this to be 3 and 5. So 3 by 5. Similarly as 3. Let's see your x. Okay, this is small x. 3 by 5. Right? Alright. So similarly, you can change anything in a half, anything in a nan value, or anything in an infinite values. Right? Okay. I think you might have got all these concepts of. Okay. So for a very simpler representation, you can specify your denominator limitations, and you can even find out those things. Okay. Now, let's say when we learn Python, like if we want to convert 34.5 in integer, what we do is we apply int and we write up this and run this. You'll get 34, right? But what if I write as integer itself of 32.5? Still I'm getting 32, right? So these are some of the calculation part of the mathematics, right? If I just say that I want s dot 1, so I'll get 1 over there. Similarly, s dot 0, 0. Now what is infinite, right? We know what is infinity and all, but how to represent infinity? And that is basically infinity. So if I just zoom it, you can see the infinity sign over there, right? So this is how it comes. If I say s dot half value, So you get half immediately, right? Like if you just say we want some nan values over there, you can even get, okay, in small attribute registry from this. All right, okay. So see, there is some errors. Cool. So it is nan. Okay. So nan is particularly called as not a number. Okay, these are not any numbers over there. Now in the complex, we have learned about the real part and the imaginary part. Let's say this is your x and this is 45 minus 70, a complex number, right? If we just see the real part of this, that is 45.0. And what is the imaginary part of this? That is minus 7.0. Exactly, right? So these are the real and imaginary part of a complex number. Now if I say, what is exactly a real number or a real part of the imaginary part of this? That is exactly the under root of minus 1, right? That is iota. So how to represent this iota? That is imaginary unit. That is your iota. Understood? So if you find the square root of this iota, I'll find it to be minus 1. How? Let's say if I write I equals S cube RT of minus 1. And if I say I multiplied by I, right? So I is equal to square root of minus 1. Now, square root of minus 1 is exactly equals to the imaginary unit, right? And run this I multiplied by I. That you will get the minus 1 value, right? So the square root of minus 1 is this I. Even if you run this, you will getting minus 1. This is how the basic things you can do with the help of mathematics, right? So you can even form an equation like kind of that. Now how we can form an equation? There many times students have confusions in that too, right? So let's say you are writing some x as, let's say this to be a symbol x, and let's say this to be y. Okay. So it's, let it be symbols then. If it is not taking, fine, done. So you can take x, y as to be the symbols, right? Now what is x? That is x. And what is y? This is y. If you see, it is kind of actually you see in your mathematics books and all, right? Okay. Now we'll just say I want to represent x plus y whole square, right? So how will I write this? So I can write it to be that my expression is x plus y whole square. Now what is the LHS? If I just see LHS. So what is LHS? That is x plus y whole square, right? That is x plus y whole square. Now what should be my RHS? It should be x square plus y square plus 2ab. Okay, sorry, we do xy. So see your RHS, and you'll find it to be x square plus 2x square plus y square. Now you can evenly put all the values of there and you can calculate up the things, right? So this is how you can make any equation up there. Alright, fine. So you can even find a sine of anything or a cos of anything, right? So that is to be there. If you write it to be x and y, and let's say again now in this kind you are taking it to be, let's say if I say from this So you can import the sine, theta, the cos, and all those things, right? You can import this theta, beta. Look, let us bring this theta and this beta. Cannot import this theta from Sympy. All right. So let ABC down. So now let's say what is the actually theta? This is a theta, right? And what is beta? This is beta looks like. So basically a mathematical module over there to make you learn how this mathematical things goes on in the programming sectors. Okay, understood. So you can even do some calculation with it. Okay, so let's just say if you are writing it to be a sine of let it to be x equals this. You see, this is your x and this is your y. Now if you write sine of x squared plus cos of x square. What is the value? Sine square x plus cos square x. That is sine square theta plus cos square theta. Right? The expression you are getting up there like that. Right? So you can even like if it is this is an expression for you, like let's say this is an x. So if it is this is an expression for you guys, you can even substitute the values even, right? You can write x dot the substitute value, right? And substitute it the x or substitute the like this is x, yeah. So substitute the x by y. So in that case, you'll be getting sine square beta plus cos square beta and like that. Okay. So some sort of mathematical calculations, even you can perform even you can perform some differentiation, the derivatives, the integration, and those things. You can even perform those high-level computations too. Like that is also very easy in terms of complicated terms of you can say coding area. Right now, how those things are done. Let's say want to see a derivative. Okay. Let's say this is simples and so you can just define it by, let's say you want a differentiation of any particular expression and the value. So let's say your expression is ex and you want to do with x. So you can see the differentiation to be 0. Why? Because this is a differentiation of a constant, right? So let's just say that if I'm taking it to be expression and I'm making it as x multiplied by the sine of x into x plus 1, right? If I see my x, so I'll get it to be theta sine theta square plus 1, right? Exactly like that. Now, if I find this differentiation of this expression with reference to this x, so I'll see it to be 0, right? What if I say it to be with the reference of this theta? Right? Okay, I think this is x. So you can find it to be 2 theta square cos theta square plus sine theta square. That is exactly the differential value when you differentiate this, right? So that I'm saying that you can even find the differentiation or you can even find the integration of any particular equation in this, right? Let's say you want to differentiate this expression, right? And we want to differentiate this square by 2, or like by x. So differentiation of exponentiation value of x squared by x. So what you'll get is 2 theta e theta square, right? That is how this things goes on. That is how this expression and all these differentiation things goes, right? So differentiation of a particular constant is always 0. We all know, right? Right? So let's just say from this Sympy, we are going to, okay, let this to be an ABC. We are going to import this differentiation, the sign. Okay, let us say to be x and y. All right. So this is x and y. Now let's say my expressions to be this, say, or else if I just even change my expressions, if I just say that I want to differentiate, so differentiate this x raised to the power of 4 with the x and the 3, so I'll get 24x, right? So if you guys remember the differentiation methods and all, you might be seeing it how these things are worked out. So let's say if I make an expression of x multiplied by sine and this is my expression. So if I see my x, this would be x sine x square plus 1, right? So what is the differentiation of this expression? Dot differentiate this with respect to x. So this is the differentiation, right? But what is the derivative of this? So if I find the derivative, the derivative of this ex would be d by dx of x sine x square plus 1. Okay. So that is all how you find out the things, right? Even you can make the simplifications, or even you can just simplify up the things. Alright. You can find the factors, and a lot of things are there. What you can do with this field of mathematics sector with the help of some data science, right? So you can do a lot of things. Okay. Now coming up with the Numpy part again. So we'll be seeing all about the data only. Okay. So what is the data distribution, right? What are the random things and what are the data distribution? So let's just say you are taking from this Numpy, when I import this random module, right? And when you are saying this random dot rand of 10, so here you will get some 10 random numbers, right? Some 10 of the random numbers. Instead, if you write even the 100, still you will get some numbers, and always you will see this to be between some 0 to 1, right? Fine. Now, these are some of the random values you can see starting from the zeros, right? But in case, guys, if we just write it's to be random dot random of 100, what is the change, right? These are some of the random values, and these are some of the random numbers you will be getting up, right? Here you will be always getting between 0 to 1, but in this case you will be getting any of the random numbers. Let it be from the negative, let it be from the positives, and like, okay. So what we'll do is we'll reshape this. Since this is 100, I will reshape this 10 by 10. And you can see now there is 10 rows and 10 columns. As reference to this, you can see there are 10 rows and 10 columns now. Right? Okay, cool. Similarly, if we don't want to print the random numbers, right? If we don't want to print up all the random numbers, what we can do is we can write up random dot choice. Now here you can write your own choice things, right? You can write up your own numbers to be printed up. Let's say you only want 1 and 2. So give the percentage what you want, like 0.5 or 0.6 or 0.4, the ratio, and the size you define has to be 50. Run this. Now here you'll get 50 numbers, right? But the 50 numbers will be only consisting of 1 and 2. And also in the ratio, like 1 will be presented for 60 times and for the 2 will be presented for 40%. Okay, that is how it will be done up. Alright, so I think it should be clear to you. Alright, fine. Now, coming up next, similarly, you can increase the percent, you can decrease the percent. Let's say you have given 0.0. So you will not get anything, right? You will get the probabilities do not sum to be 0. Or like 0.0. It's not done with that, right? You can even take 0.1. That is possible, right? So 0.4 and 0.1. So you'll have to change it to be, let's say you'll have totally give it as 1.0, and then you can give it 0.0 and you can run this. So in that case, so every time the probabilities you will be giving there, the percentage of the probabilities you can say will be giving up there, it should be always 1.0, right? So once you have given 1.0, like the total probabilities comes to be 1.0, then it's okay. If it is not like that, then it will raise some errors to you, okay? So in this case, you can see only 2 has been printed. Why? Because in the only 2 we have given 1.0 and this is completely 0. So let's say even if I write 0.9% and this to be 0.1, so it should be totally changed, right? You can see the 2 as 0.1, that is 1%, and all these 1% of 50 is 2, right? If you just want to find 1% of 50, you can even do some of the calculations with that, right? So let's say that if we just want pi r square. So how to represent pi r square? This is your pi r square. Okay. This is a pi x square. So this is how it looks, pi x square. Right? Okay. So these are actually the mathematical representations of your data sets or the data you can perform on. Okay. Alright, moving up. Now let's just say in the data distribution part you have seen, right? But let's say you want the LCM of all these 1 and 2, right? Let this to be a S, and you have printed this S, and you want an LCM of this thing. Now LCM in this thing is like, you just want LCM np.lcm of, let's say 2 and 4. So the LCM of 2 and 4 would be 4. Now what if I want to find the LCM of all those things? So in that case I can find LCM dot reduce, and then you can write up the array name what you want. This to be M. Yes. So you can find the LCM of this 2 and 1 to be 2. Write that. Okay. This is one of the very important thing, like when dealing up with the arrays. Okay. Fine. Similarly, you can find the HCFs and all. That is also same, right? Okay. Moving on. As I said, Like you can perform the differentiation. Similarly, in the way you can even perform the integration part, right? Now, in the integration part is also easy actually. Okay, but before that, we'll complete up the Numpy, right? Now, let's say, guys, if you want to find a range of numbers inside this Numpy, you can use this arrange. So let's say you want 300. So you can find a range of 300 and you'll get some 300 numbers over there, starting from 0 to 299, right? So how to represent this integration and all those things? Let's say you want an integral. If you remember up all these things, let's say you want an integral of log x, and you say log x square, and with respect to x. So integral of log x square with the dx will look something like this, right? So like that. Okay, so let's just say this is an expression and this is your ex. So you'll get the values of there. Now let's say if we use do it, right? So do it will give you the integration of this and will give you the value, that is x log x square minus 2x log x plus 2x, exactly the integration of those things, right? That is how it is done, right? So you can even take up the things like, if you remember in the trigonometry, we do it like kind of minus infinity to infinite values and all those things, right? Okay, this is how integral happens, and you can see integration happens here, right? So let's just say that there is an expression, let to be ex, and you're writing it to be x squared plus x and plus 1. A very basic expression, right? X squared plus x plus 1. If we go for integrating it, what would be the integration? That is x cubed by 3 plus x squared plus by 2 plus x, right? And with respect to x, if it does. So integrate of this expression with respect to x. Okay, with respect to the x, if we just solve on these things, we'll get it to be x cubed by 3 plus x squared by 2 plus x, like that. But let's say, now if we modify it and if I say it to be sine of x multiplied by the tan of x, right? So what would be the expression? That is sine x tan x, right? Now, if in this case, if you just go for integrating this expression with respect to this x, we'll see it to be minus log of sine of x minus 1 by 2 and all these things, right? So these are some of the mathematical cases what you can perform with this Python, okay? That is actually another domain to work on. These comes actually in the data science fields where you explore of the contents. Okay, moving up. So I think NumPy is very much clear to you, right? So we are not going to explore all those things in the NumPy, but a basic different thing, right? So let's say if we just want to plot a graph with that respect, so let's take it to be arrange. So arrange of 0 to 3 and let it be a pi value and the intervals in the 0.1 and y to be np dot sine of x. Similarly, if I just plot it x and y, so we'll quickly see a graph that is a sine graph. Okay, that is exactly a sine graph. Now let's say if we just take up tan, right? Plt dot say z is equals to np dot tan of x, and we plot x versus z. We'll see a tan graph there, right? Okay, the sine versus the tan. right? Okay, now let's say you want to give some labels to your graph. You can use this x label as x axis. You can get x axis over there. Similarly, you can use y labels and the titles to create up your graphs over there, right? So these are all what you can do with the use of this Numpy, right? So let's just say that if it is at the set of numbers, let it to be 1, 4, 16, 25, 36, and like that. All right, the syntax error, fine. So 1, 4, 16, 25, and 36 over there, right? Now, these are actually, if you see it very clearly, we have taken some squares of the 1, 2, 4, 5, and 6. So missed the 3 there up. So 9. Fine. Now we just want to find the square root of all these. We'll be using sqrt of v. We'll be getting up to be 1, 2, 3, 4, 5, 6. That is exactly the square root of all these, right? So similarly, if you want to find the log of all these v, you'll get the log value. And also if you want to find this to the base of the 10, you'll get the log value with the base of the 10, right? So these can be done with the help of this, you can say Numpy, right? Now let's just say, guys, you are having one expression, right? Just say this is an expression and that is like x squared and z. Okay, so x squared z plus, let's say, 4xyz and also will take up to be 4y squared z. Okay, so this to be the expression, and before that what we'll do is alright. So x, y, and z are particularly the x, y, and z, right? That is the symbols. If you see the expression, it would be x square z plus 4xyz plus 4y square z, right? Okay. Now, so this is a particular equation you are getting up there, right? Okay. Now if you want to factorize this, right? If you just want to factorize these things, what we can use is factor. So if we just apply factor of this expression, we'll not have to solve of the things, and this is the factorization of this particular equation, that is z x. And if you also want to find the code of this, you can even write it so for math ml code and you can get it there. That is the code of this one, right? Okay, so this is very clear, I think, right? You can even modify the things over there with your own. Okay, moving up. Fine. So this is how you can factorize, right? You can collect, you can even cancel, or like if you want to cancel, or if you want to find the trigonometry or power of anything, right? If you want to minimize any trigonometric equation. So let's just say that this is your expression and this is 2 sine so 2 sine square theta, 2 cos square theta. see your Ex, that is 2 sine square x and plus 2 cos square x. That is nice, right? Okay. Now, let's just say if you want to factorize it, can you use this factor over here if you just want to factorize this expression Ex and run this? So you'll get 2 and then sine square x plus cos square x. That is the very basic factorization we'll get, right? That's a basic thing. But what if in this case, if we just want to make it as a factorization, right? If you just want, that is like if you just want to factorize in the terms of the trigonometry, what is the value? Sine square x plus cos square x is equals to 1, right? So it should be 2, not as 2 and then sine square x plus cos square x, right? If we just factor it, it should be like that, right? But after factorization, if we just manually solve it, it should be 2, right? But how to get that 2? For that, you have a trigsym that is used to simplify the trigonometric identities. So you can apply this trigsym and you can write this expression over there and you'll get the value is that is 2 in that case. Okay, so that is used to simplify all these trigonometric identities, and you can even find the cosine, the cos, and all those things. Okay, I hope this is clear to you, right? So let's just say there is an expression, and let's say it's to be x to the power of y and to the power of x z y to the power of z. Now run this. So see your expression, that should be x to the power of y, x to the power of z, and y to the power of z. That's it, to be x, y to the power of x, right? I want to find the expression, right? If you want to reduce this expression of x to the power of y, x to the power of z, and y to the power of x, want to just reduce this by combining their bases and exponents, if you say, in that case. So what we can do is we can use this power is a power sim and use this expression. Not defined. Okay. So you can find it to be x of y plus z and the y of x, right? That is, these two bases are same, right? This powers will be added up, y plus z, and you'll be getting this to be y of x. Now let it be, if it would be an x of all those things, then you would have got the exact values of those things, right? I think that is to be clear to you guys, right? So let's say if you was just want a factorial of some 5, so that is 120 exactly, right? But you want to represent an expression of factorial of any particular number, right? Let it to be of x or any such things. So factorial of x. So what is your expr? That is x factorial, right? So we just represent this as factorial of this x divided by factorial of this, let's say x minus 1. So this is factorial of x by factorial of x minus 1. That's how it get to be, right? Basic functionalities of the factorial methods and all, where you can just combine up the things and can solve up these things, right? Similarly, you can use this if you want to find the combinatorial expressions. You can use it as, let's say this is let's say this is a binomial and we are using it to be x plus 1, y plus 1, and let's form a binomial expression x and y. So you can get the x plus 1 and the y plus 1. This is an expression of a binomial one, right? So we write it as a binomial. So there are a lot of operations to be operated. Let's say binomial of x plus y, we'll get it to be x and y, right? So a combinatorial form of, you can say. Okay, so that is actually how written up there, right? Basic things. Now, so this is like how you deal up with the Numpy, right? And that is, I think it should be clear to you guys. Now moving up, let's just say now we are going up to the matplotlib section, right? And I'll give you some 1 or 2, 3 graphs to show you how these things are plotted up, right? So you might have seen now how we can just plot up the things over there in the matplotlib. You can quickly use any of these plotting methods and you can just find out the things. Let's say now we'll make a function and we'll plot at something over there. So let this be a function of f of t. And it will be returning you the exponentiation of this minus t multiplied by the cos of if I, so this will be the use of the function. Okay, the separates. Let's write it here. Let's say this is my t1, which is my np dot range of 0.0, 5.0 and the interval of 0.1. Similarly, I'll take t2, that will be a range of 0.0 till 5.0 in the intervals of 0.02, right? Now let's say we are plotting some 2 graphs, so we'll be using subplot. So 2 to 1. So this is the first plot I'll be using, that is PLT plot. And let's say we are plotting this T1 and the F1. And let's say F of T1. T2, F of T2, right? So blue 0 means, BO means blue colors, right? And the blue dots. Okay. Moving on.